All right. Is artificial general intelligence possible? Is it possible with the current technology or architecture? I read a paper here recently and reviewed this Hugging GPT, and the results were impressive. It definitely seems plausible, and they do a really good job of explaining how it can be accomplished with modern day technology, architecture, and a well-defined stack. So looking at the paper that was reviewed, it was this one right here. Um, Fantastic research, really well laid out, lots of very detailed documentation around the way that the technology stack works, the processing of the models, and also the prompt engineering and responses that came out of it. So a very good paper. I highly recommend reading it, and the link will be in the presentation here. So moving on to the PowerPoint presentation I put together for this. So once again, I'm reviewing a scientific paper done here by Hugging GPT, and looking at some of the results of their experimentation. So, starting off, the problem statement was models currently today are very specialized. They look at being able to do things with images like object detection, classification. You, of course, have things like large language models that do things such as search through a corpus of data. They do some kind of response to a prompt you have and give you feedback. But there's not really a model that exists that really comes close to artificial general intelligence where it can just carry out any task that you ask for it. So what this project proposes to do is use that large language model to actually go out and use other models in existence. So just like today for large language models or image generation, we take a large data set scraped off the internet, and we use that to actually give results, through various training of our deep learning models, machine learning models. What this proposes to do is take that one step further and actually utilize models that are published on the internet to serve this general intelligence um, proposition, where they actually go out, they look, they find the proper model to carry out the task, and then give the results based on what you typically would expect from those specialized models today. So getting into this, first off, I'll start. The model selection is used by Hugging Faces. For anybody that hasn't seen Hugging Faces, we'll go show it quickly. It's an AI community with a bunch of different models. If we go to models here, there's thousands of models. Some of them are very specialized, some are more generalized. And if I would just pick something under the computer vision topic, like object detection, this gives you an idea of, just how many models are published, 13 pages of these. And we can look at these. Something very special using YOLO for object detection. And this is hard hat detection. So something very specific and specialized. You can look at how many downloads occurred during the month. That kind of gives you an indication of the popularity, or how useful this is to people looking for that specific functionality. We look through some other stuff. We have forklift detection, just very, very specialized instances. But you can have other ones that are more generalized. You have airplane, bus, person, very general object detection in there. So really, it's a challenge to look through and sort through all these and try to determine what kind of model you need for your specific task. But the possibilities are endless. You see all the different. You have multimodals. Having multiple faceted models. You have very every variation of computer vision you could use, natural language processing, auto, tabular, reinforcement learning type stuff. So really, there's a lot of everything out here, and most of them are very specific, trained on very specific data sets. So that helps, the performance in those specific cases. But when you have general activities that need to take place, you really need to sort through and find the one that fits your needs. And really, getting back to the presentation, that's what HuggingGPT goes and tries to accomplish. So they do this through this stack. They have task planning, model selection, task execution, and response generation. So getting, kind of into each area of that stack. On the task planning, they use a large language model. In this case, they use ChatGPT, and they take the initial prompt that was given. So it could be a very large prompt asking for several things to occur. And then what ChatGPT does is they breaks it out into individual tasks that can be accomplished by a single model, and then prompt engineers a prompt for that type of model so that they can carry out the certain task for each model. Next, it moves to the model selection. And on the model selection, I posted an image just showing how many models are in each object category. And as you saw, this is just a very small subset of what's available. But for the model selection, what it does is it scrapes the description from the model that the developer puts out there, and it parses through there looking for the capabilities that match what was asked for it in the prompt, and then it picks the right models that possess that capability. And to finalize which ones actually use, because there's usually more than just one in that particular category, it looks at the amount of downloads for that. And, it's just kind of a very quick way to vet, is this model useful? If it's got a lot of downloads, then it's theorized that, it's probably works decently well, and that it, has some accuracy to it. We'll talk a little bit more about that and some of the limitations a little bit later on. Next, we look at task execution. So once that model is selected, those prompts were engineered in the first step. API calls are made to each task of the model to get that piece of the puzzle. So if you feed an image and you're looking for a pose, it'll go to a model that diagrams the pose and gives you some kind of result back, some stick figure model. If it looks for object detection, it'll send to a model that'll do the object detection and possibly classification of what was detected in those images. One of the difficulties with this is if it's a very complex prompt, you need to schedule which task occur in which sequence. There's a sequential dependency amongst these. So you can't move on to one step, say if it's looking and identifying a pose, before you can go to image generation based on that pose. So the output of one step is usually the input for the next step. So these researchers did a generic scheduler just to help with that sequencing, working off API calls, responses, looking at what the response was for there. And then the other thing that task execution does is it collects the artifacts. So whatever images are generated, text generated, whatever the case may be for each model, it puts those in a certain directory and on your hard drive, and then it allows you to reference that. And in the next step, which is the response generation, it'll actually go through and provide you details. It'll tell you what model was used, a vague description of the prompt that was used on that model, as well as giving you links to all the artifacts that were created along the process. So you can kind of walk through and say, well, I see my end result, but also look at the results that occurred through every step of the process. And that way, if you need to go back and do further prompt engineering or tweak things to really get the results you want, you're able to see how things worked along the way. So showing an example output here, the query was generate a video with the title "Astronaut is Walking in Space" and dub it. So the response, as you can see, says, sure, typical ChatGPT kind of verbiage. Sure, I've generated a video with the title "An Astronaut is Walking in Space" and dubbed it. The workflow I used is as follows, and it'll show you the model that was used to generate the video. It'll give you a link to the actual video that was created. It'll show you then, secondly, use the text-to-speech model. It'll show you the audio that was generated, and then tells you that it combined these as the final step. And here goes your video that does this. And this is an example of something that worked out quite well. The model was able to handle that quite elegantly, and it was results as expected. Here's another one of multimodal cooperation. So in this multi-modal, you look at several different steps here. I won't read through everything, but it was fed 3 images and asked to look through these 3 images, do some object detection, and also do a count of how many zebras were in here. So you can see, in the end result, it was able to tell you there's 4 zebras, correctly identifying everything from all 3 pictures and showing you, how many images it looked through and gave you a nice count. And this worked well. And this was quite a complex task for this to go through, find, a model for object detection, find a model for not just object classification, but one that had in its training set zebras and cats so that they could be identified. I mean, we're all pretty familiar with cats and dogs classification. There might be some other animal ones, but these aren't necessarily, 2 animals that are in the same training data or the training set usually. So, it was impressive that I was able to do this and do it quite accurately. Um, However, there are some limitations. So when you get into giving these prompts and the fact that they got to break down into a very specific task for each thing that needs accomplished along the way, there's limitations on ChatGPT and others on the prompt size, how many tokens it takes, and that also comes into cost, right? Most of these models like ChatGPT, if you're doing any significant amount of prompting, then it ends up using, a lot of financial resources to do so. So that's one problem. The other problem is model specific intricacies. So if you look at specific models, the more you prompt it and see the results, the more you can engineer those results to give you the output that you desire. With this model parsing through and picking at runtime what model it wants to use as part of this, it may not give you the results you want because you don't have the opportunity to engineer the prompt with that kind of specificity. So, there's some opportunities in there to actually look at and do further vetting on the model so that you can actually put some logic into the code to give better prompts to get more accurate responses. And then latency is an issue because with the sequential nature of this, each model takes, in some cases, quite a while to respond, particularly because this is a experimental project. It's not commercialized where there's contracts between the different model providers. You don't have SLAs on the API calls. You don't even have a guarantee that they'll actually return a results. There's quite often people experience problems with ChatGPT, Dolly, Midjourney, wherever where there's high volume and results can't be given. So you do have some of those problems around latencies, SLAs, and just performance in general. But that's something that can definitely be fixed and relatively easily in a commercial model. So that comes down to the time factor as well, going sequentially through all these models without guarantees on performance. The other limitation is output. So this was an interesting one where the query basically was looking at a basketball player flying through the air for a dunk, and it wanted the model to take this basketball player's pose, arm up in the air, the legs kind of out in this manner, and apply it to a young boy, whether that young boy was flying through the air to dunk the basketball in the hoop or riding the scooter. In the process of doing it, it was really the context of, dunking into a basketball basket in this pose. And what happened in this one is actually a little bit shocking but unique. This is the output it gave. So you see here, they put a basket on the bike and, the basket was in front of the boy. So that was accurate in the context of the prompt, but not necessarily the output that the prompter wanted. And then what's really unique is the pose of right from the arm up. The leg positioning on the pedals is exactly like the basketball player. However, the AI model determined that this is also a very appropriate position for riding a bicycle. So, it's very unique and it shows that without further modification and really looking at getting specific with those prompts that you may have results that are quite different than what was expected. So, some of the relationship to the um, AI, ethics, privacy, and geospatial data classes, we have intellectual property concerns that are very similar to the things discussed around Dolly, Midjourney, and others. So all the models being utilized on Hugging Face, they they scrape data from the internet, so you still have those intellectual property concerns there. And do people have rights? Do they have copyrights on them? Are they getting proper credit for images that might be used of art to generate art through this model? But the problem's extended because you have intellectual property concerns over the models used. Now, while right now the response generation is telling you exactly what models it used, giving credit to those models, thinking through a commercialization of a project like this, it's more than likely not going to give you those prompts and tell you what models it used or give you as much detail in the response generation that was really for researcher purposes to be able to track what's happening and understand what's going on under the on the back end of this model. But in a commercialized setting, that would really take away some of the market advantage, letting your competitors know what models you're using, how you prompt them, and it really doesn't add anything to the user experience because really the user just cares about the end results and not how they got there. So that more than likely would be gone. So then you have that intellectual property concern around who created the model, who should get credit for that. And that really furthers the problem of the intellectual property on art and text and other things that are used to train these models, because without the ability to trace back to what model created the output, it gets even more difficult to trace the training data. And then you also could have issues where maybe there's a voting system that takes place where you have results of multiple models that do the same thing. And then those are kind of combined into one result. Then you really have blurred lines of where the actual intellectual property rights lie. The other thing that could happen is licensing an agreement for acceptable terms. So you use a lot of these AI models, you see it in Dolly, ChatGPT, and others. They have acceptability terms, what you can use these models for, what you can and cannot do. Well, how do you expend, usage of this AGI model that attempts to be the controller and proxy and coordinate all these models, and still write in the legal obligations verbiage into that acceptable use policy? That becomes almost impossible, in particular, because the whole premise of this is to be able to take the latest and greatest, whatever's published, and scrape these models and utilize them for use from anything that's published, not just very primary models that are out there. It takes the same spirit of scraping data from the internet and applies it to these models. So that becomes a little bit of a legal concern as well with these licensing agreements. So, opportunities to improve in the model. Once again, I was really impressed with this work. It really makes me feel like artificial general intelligence is quite feasible, but it is also very feasible with the right logic and methodology behind creating it with current architecture and technology. And it's really starting to become an architectural concern given the research done in this paper, and not so much a matter of creating new types of models, but just really learning how to leverage and utilize what's out there now and put something together that really lends itself and pushes the AI community towards artificial general intelligence. So that being said, a couple of quick areas of improvement, especially if this would move more to a formal setting and just not research, would be rigorous vetting of models used to improve the consistency of results. So instead of just pulling from the thousands of models that are out there, maybe look at the top models in each category that really covers most use cases, and then thoroughly vet the accuracy of them and do some prompt engineering that's very specific to each one of those models. So there's a correlation between the prompt that's generated in stage one and the one that's used for the model selected, and that would really lend itself to a lot more accuracy. Latency things could be leveraged, such as putting specific SLAs together with either Hugging Face or specific models within there, and have maybe specialized API calls for this commercial usage. So there's guarantees around there as far as speed, the latency, uptime, availability, and some other considerations that you'd want to have to fully utilize this on a commercial basis. And even if that means just releasing it to the public as a paid service to play around with, like you see with some other models. But in conclusion, and once again, this is a very exciting step in the pursuit of AGI, and the potential for improvement with the existing technologies and technologies is certainly there. Yeah, I think it's going to be very attainable with just the current technologies that's out there, just by perfecting and moving beyond the single model approach, but really building a entire technology stack and a full architectural backbone that supports the kind of move towards AGI. So overall, this was very impressive work, and very interesting to research and follow along with. Thank you.